Welcome back over to theCUBE's live coverage of Supercomputing 2025. I'm John Furrier, host of theCUBE, with Jackie McGuire with theCUBE Research, breaking down all the action on the AI infrastructure, build out the innovation, what it's going to enable and bring in the wave of AI native applications. We got two great guests here, Chris Sullivan, Director of Research, Academic at Oregon State University, and Seamus Jones, Director of Dell Technical Marketing Engineering at Dell Technologies. Seamus, great to see you. Josh, welcome back.
Yeah,
thank you. Set again for an encore performance.
Yeah, I really appreciate you guys having us talk about this stuff.
Seamus and I have had many conversations in the past around some of the technical engineering he's working on, you know, bringing the AI factory, bringing in the big iron, as it used to be called in the old days, is really the supercomputing era now, is these AI hyperscale systems. Yep. HPC meets AI is all computing.
It is.
You guys doing some amazing things. What's the focus?
So, you know, we work with Dell to try and change the way we're doing science, and Dell devotes engineers and time to this, and we're really focused right now on a project around plankton, because it's actually about ocean health and about climate change. And plankton produce about 50% of the oxygen you breathe. It's about 25% of the carbon sink on this planet. It's 17% of the food you eat. So if you like to breathe and eat, it's kind of important.
I do. Yeah. We don't know what's going on there. Is it working?
And so what we do is we've written an algorithm where I can actually go out there and monitor and classify all the plankton using AI. And we take them on these gigantic ships that cost us $150 million a piece to build. We're building 3 of them right now. And we're working with Dell to decide what that data center on that ship is going to look like. Okay, and so we have to test the hardware before I go back to my granting agencies and say, this is what we need to do. And so Dell partners with us to determine how we need to proceed forward. We did this before with our Ocean Observatory initiative, and now we're trying to do this with how we do plankton. One of the reasons we need to do this is so important to put it at the edge is because the ship cost me $1 million to run just for 10 days in the ocean. And if I was to put things into the ocean and come back with no data, that would probably be bad. Yep. And so what we really wanted to do is move to what we call adaptive sampling, where I can actually put something into the ocean and use technology to help us understand what we're getting back in semi-real time or real time, and then ultimately be able to move the boat around if I need to and ensure that as we're doing our experiment, it's working.
So data ingestion.
The researchers who are out on the boat, so they're able to understand, manipulate, and change their tactics on the boat real time based on the data that's being produced within that box.
And one of the limits we saw before was we were putting power scales and things like this out there, but we had to keep moving data around. And so what Dell's helped us to do is partner with Solidigm to actually bring what we consider large capacity SSD drives in. Yeah. And we were able to put hundreds of terabytes onto a single XE7745, and the machine just took flight.
That's been one of the recurring themes from a lot of the guests we've had on, is that storage is oftentimes like the back of mind thought when we're all excited about compute and capacity and throughput, but if you don't have anywhere to store what you're computing and putting through, it's useless, right?
Yeah. Or the fact that I paid a bunch of money for this GPU processing, but I'm spending all my time moving the data around, I'm not processing it.
Yeah. So scope the problem, because I liked where you're going. You got the boat cost, that's clear, fixed costs. Yeah. Now you're saying, okay, our goal is to get plankton data. Yeah. And so that's data ingestion. So you want to maximize the data collection and get the scientists performing to the best of their ability. It kind of lines up to an AI use case that's in line with getting more productivity and creativity out of the asset, which is the human, and the machine.
There's a temporal aspect to this data. If I can't process it in a meaningful timeline, I can't tell you what's going wrong with the planet. I can't tell you how we're affecting it. We can't make positive change.
So how do you scope that? So you got to sit, you zoom out, you call Seamus up at Dell. Okay, how do you attack that problem? How do you scope it?
So I mean, Dell's been a partner at Oregon State University for decades. This is not a new thing. And so they come to us and say, what are your problems? And I just dump on them. Okay, he's good at that. I'm really good at this. And I basically just lay it out, and then they give me engineers that are really impressive, that help me navigate the process and overcome our hardware problems and our hardware limits. And I know that that's always the case. The other thing I think everybody needs to realize is that there's a compliance aspect to this. This is a $150 million ship with multiple government agencies on it.
In the east, the Far East, or here in where are we?
St. Louis.
St. Louis, yes. I've lost track of
it.
There's
a river.
I've lost track.
Barges out there that can get some plankton.
Yeah, somebody recommended I go to a seafood restaurant a couple days ago.
It's one of those things that we want to have a support structure to be able to support it anywhere we go.
Yeah.
The other thing you need to realize, I don't have people out there to work on the machines. I don't have computing people in that data center. The machines have to be bulletproof, and they have to never fail. And that's part of why we choose this.
It's coming an autonomous story, but this translates, Seamus, to other use cases because, generically it's the same problem statement, scope and demand. You got to have computing that works.
When our engineers put together the plans for the 7745, the XE7745, one key or critical component was to make sure that, look, we can ensure that we've got CPU that can scale, we've got memory architectures that can deal with the workload, we've got hard drive capability and capacity, and then also GPU availability, right? And within those GPU frameworks, some customers are going to want to have 16 single width GPUs, 75 watt GPUs. Some are going to want to have 8 of the 600 watt full double width GPUs.
The 6000s,
the RTX Pro 6000s. And the key thing for us is to give customers that flexibility. Yeah. Not only that, but we want to have it in an air-cooled chassis. And the RTX Pro 6000 can give us a lot more flexibility for things like CFD and research, and then also look at other models. Like we can run multiple models on that platform.
I just love the idea of the boat data center. It's like space when you're out in the water. It's hard to do break fix when you're way out in the Pacific.
As we build these ships, we're building 3 of them. They're $150 million a piece. One will be in the Pacific, one will be in the Gulf, and one will be on the East Coast. We look at them as being the predecessor to the Starship Enterprise. Yeah. That's a research vessel in the future, and this is our beginning effort to do that. Before this, we had research vessels that were actually naval vessels we retrofitted, and our people had to throw equipment off the boats and stuff like this. We're finally going to have the apparatus to put things in the water properly.
These are built from scratch. You guys
These are built from scratch.
All right, so what is the data center?
And the 7745 just took off. It is the most amazing one for edge, especially if you have that type of a data center. And so we really felt like this was the pathway forward for us, and we are now going to be submitting that towards NSF to try and build out those 3 boats with this.
I'm curious on the connectivity, because you see an automotive, similar kind of thinking around designing, say, cars or robo-taxis. It's a rolling factory. It's got everything in there. You got the boat. Is there a self-contained data center? Is there connectivity back?
So I just went ahead and put a 100 gig line down the dock and a 200 gig line back to my data center.
It's a lot of Ethernet. It's like we have spool after spool of Ethernet.
We have Link Oregon, who ties all of our universities together, and he actually upgraded to 400 gig right now, and so I actually lied. It's probably at 400 gig to the ocean, and we use that pretty extensively. So even though I'm doing some processing at the edge, it's too much. And right now, one trip for 10 days, I gather 100 tera of just one experiment. I have 14 other experiments going on at the same time. And you take that one experiment, it turns in about half a petabyte. And so, we still need to keep all that data for retraining. It is a big data problem.
So how do you think about resiliency out on a ship in the middle of...
So that's where Solidigm comes in. So Solidigm, the drives are so large that I can have redundancy and resiliency built into the systems and still have the speed.
Still have enough speed.
Yeah, so we were actually able to put a bunch of Solidigm drives onto the Dells, with their help, of course, and they were mind-blowingly good. And so we had tons of space. I never had to move the data around. It landed, we were processing, we were storing, all in one spot.
Awesome.
And it actually gave me a 3x performance increase from having to move things around and do this little dance. And I really saw that both in performance and not having to move.
And Seamus, I know that Dell is hyper-focused on resiliency right now. I've actually had a handful of conversations with different product people at Dell around this because we're pretty focused on it too, because previously, if you have a server crash, you might miss a little, like 5 years ago, that's a little bit of data you don't collect. The velocity and
what it does is it ensures that you're spending funding on these component parts. You need to make sure that you're actually getting actual performance out of them and not artificially bottlenecking somewhere within the architecture.
Yep.
I think that's where Dell's scale is a real benefit, is that you've done so many different critical operations in remote locations. Everybody wants to be with wants to buy from the new hot company, but there is some benefit in like, hey, there are very few things we haven't seen. We've got lots of large customers trying to do really cutting edge things. So that's one of the things that really resonated with me at DTW was virtually every customer I talked to, one of the first words out of their mouth was partnered. We partnered with Dell, they helped us do this, they brought people in, and it seems like to a much larger extent than some of the other companies we hear from their customers, they really do look at you as a partner, and they're not afraid to call. They're not afraid to use you as a technological therapist.
That's where the second use case came from. A professor at DTW approached us at one of our booths and said, I'm having this problem at our university.
Chris said you're his therapist, and I've got some things I want to talk to you about.
Right?
Yeah, so we actually got a lot of excitement around this XE7745. And we started working with a professor in business. I'm not in business, but we recognized that we also were working on teaching and looking at this. So we partnered with them, and Dell, of course, and Metrum AI to actually build a grading tool using AI that will actually help our teachers grade the assignments more consistently, more accurately, and at a much better pace. If I have 300 students submitting something into a class and a professor has to go through that, it takes too long for them to, and by the time they get in the middle, they're changing how they graded from where they began.
And they're hangry, and they want to go to bed. I imagine it makes it more objective too, right?
So there was two problems that this professor came to us with. One was the fact that I do have a different grading schematic at the end versus the beginning, right? Because when you're at the end of your course load, holy cow.
But it's hard not to let the first few impact. If you get two really good ones at the beginning, everybody else is getting killed.
Else is screwed.
The second was that we really want to make sure at the end of the course that we have knowledge transfer. And with AI helping students to learn nowadays, sometimes that knowledge transfer doesn't necessarily happen.
Got it.
So one of the things that we wanted to do within the use case was actually the students are building out videos. They're doing the pitch effectively to explain they're doing an oral exam at the end of each of the coursework. And the professor then uploads this oral exam that's videotaped into our tool that Metrum AI have developed for us.
Correct.
And it uses 3 models to analyze and grade that to give back to the professor.
Yep. And it happens in minutes.
Yeah.
We're talking minutes.
We can handle, in a single XE7745, we can handle every student at Oregon State University, over 40,000 submissions in 1 week.
So this is crossing over from the AI at sea.
Yes.
And now you have in academia.
Yeah.
Blocking and tackling work's got to get done.
Yeah.
Is there other cross-pollinations? I can imagine that you can integrate the research, student interactions
We are actually. We let our students directly interact with these pieces of hardware. It's very important. We're trying to build a workforce, and we recognize that a lot of these groups don't have infrastructure people coming forward. And so Dell and I allow the students to get access to the hardware. I have pictures of the undergrads standing around pointing at the XE7745 because they're like, how do I get access to this right now? They're in our data center. They're helping us rack. They're helping us deploy these things because in the end, computer science as a discipline is changing.
Yeah.
And we need to help meet that change and empower the workforce.
And John, the common component in both of these is the same platform.
Yeah.
So you're using a universal platform that you can do in multiple different frameworks.
You look at what NVIDIA is doing with the AI Factory and what Dell's AI Factory is with NVIDIA is interesting because the libraries are coming out in these domains, so domain expertise crosses over. You got that common software, so you got the libraries, and you got the models. Now you got the factory, so you're starting to see kind of like almost horizontal scale with the supercomputing without kind of like siloed deployments.
It's truly, that's what it is.
And you see more of those models being run simultaneously on the same system. In this use case, we had what was it? Qwen, Gemma and Whisper.
Exactly.
So all three models running simultaneously on the same system.
The work you guys are doing with the ratings is, I think, a tell sign to where some of the software tooling is going to emerge for students and the professors, because when you have that kind of AI on the student side, they're probably all using AI too.
Well, of course
they're producing great products.
I want them to do that because this is the greatest time for scientists. We used to have to lean into getting, research software engineers and computer scientists to help us. Now we have the ability to take our questions there and start walking through them. And so we are actually also doing LLMs and chatbots on the machine. Look,
even
too
more.
many people want access to the 7745.
That's just vibe coding on the weekend, by the way.
The machine, because those RTX 6000s are super sexy and they're really amazing for inference workloads and stuff like this. It's probably just the most amazing machine we've had in a while.
Chris, what you're doing is interesting because you have this concept that's transcending tech and now output, breaking down the walls between the teachers and the students and the research.
Yes.
Combining them together.
Yeah.
That is like will change education.
Well, hopefully in industry too. We talked about this yesterday.
I want them to not only use the hardware, I want them to help us write the software. So students and my undergrads get on the publications. I have 50 publications and 10,000 citations, and my undergrads are there with me. Okay, and when they walk out of the university with a publication behind their name, they're hired in a millisecond. Okay, and when they can talk about the hardware that they've been using at the level that we're talking, they're just walking into jobs.
All right, now translate that, connect the dots, I say, to computer science, because academia had a computer science. When I got my degree in the 80s, you had to learn operating system, database, compiler, pretty much with the tracks. Now it's evolved into data science. The aperture of computer science has changed. Now you got coding assistants. So I won't say degrees are irrelevant, but they're becoming less.
Well, you want
the entry level.
We want employees that know how to use these tools, right? That are coming out.
How is the computer science curriculum changing?
What we need is the computer scientists to go back to the compiled languages. Leave the scripting languages for scientists, go back to the compiled languages, and do the embedding coding and enable this hardware to do the things we can't do the other way. That's where we need them. And we don't want them to get the easy money anymore just writing Python. We got to go back and have them write the C, the C++.
No, that easy money goes to the researchers.
Some of us are good
She's a Python developer, but don't be offended. But this is actually interesting, because we've been talking about this in the CUBE pod. There's a throwback to systems thinking.
Yes.
And this is like old school computer revolution days.
The hardware defines the limit. Yes.
And it's become kind of a philanthropic effort to teach, because what they're getting paid versus the time they're having to put in on things that aren't teaching is really difficult. And so with tools like this, one of the things you and I were talking about is this kind of fundamental disconnect between academia and the private sector, and the fact that by the time someone gets out of the private sector, becomes a professor, that technology is years old at that point. And so if we can remove some of this just operational burden from professors, enable them to work more closely with companies like Dell, then the information they're bringing their students is from now. It's not from when this curriculum was written 3 years ago, but I've been so busy grading papers 8 hours a day, I haven't been able to go do the research. And so, because when I went to college, I was already a stockbroker. I was working at Fidelity, I was in finance, and I got an economics and finance degree, and I actually had a professor email me one time and say, well, we appreciate your contributions to the class about how things really work. I also have a curriculum to get through.
Oh, wow.
And I was like, but you're teaching people that the market works a way that it doesn't actually work in practice. Yes, that's the theory, but the Federal Reserve requirement is not actually how interest rates work, things like this.
Yeah.
And so my hope is that for the future, this really enables professors to live more in the technology they're passionate about and not in 100 papers to grade. So how else do you think this is going to impact?
So we really are at that paradigm shift because the students know the professors are using language models, LLMs, ChatGPT, Copilot, to help them do things. And we need to recognize that they're going to be using this too. The past, like you said, it was throwing information at the students, and at a class of 300, only 5 of them pretty much got it, and that you felt like you checked the box, you handed them the information, whether they used it or not is up to them. And what we ultimately did is we let the students exit the university with knowledge, but not an ability to get a job.
Yeah.
Okay? And what we want to change is towards mentoring them, and leverage the AI to help us change that to our mentoring, and then push them in the direction that they want to go to get the jobs that they're looking for.
Yeah, and you're seeing the research side. I want to come back to the AI at sea because now that you have the boats, what's that look like from a data lake, data ocean, you kind of metaphor? What's the combination of the collective intelligence now? You're going to have a bunch of people connecting into the data. What's that look like from a discovery standpoint? How is AI going to help the throughput of
when we look at
research?
the plankton, one of the things we're trying to understand is how temperature in the water changes what plankton are there, and that ultimately changes the biomass, and that is basis of our food web. So we have to have billions of these little animals to help feed the next larger animals, et cetera. And then also oxygen production. And so what we've done this summer with the help from Dell is to change to actually calculating biomass. We also recognize that we used to use nets. So if I put a net in the water and I pull it up, it looks like everything's in the same spot. Okay? Whereas now with the devices we're using, we're going up and down in the water, so I can tell you what the depth is and the temperature at that depth, and we can see that the plankton are separating. And so the predator and the prey are not mixing because of temperatures, and this changes our food source down the road.
So Jensen Huang was talking about this at GTC in DC, but here, Ian of NVIDIA was on stage Monday talking about the three waves of we're living in. Simulation, AI, and quantum. That's kind of like those step function growth curve that NVIDIA pitched. Simulations, a big part of the AI factories. How are you guys thinking about using that data to run simulations? I'm imagining that's probably going to be a big part of it.
I run a lot of simulations on our stuff. We are monitoring things like ocean mixing. So as one current comes down, like the Aleutian currents come down, they mix with the other currents. And so we have cold waters mixing with warm waters, and this changes our plankton, and this changes how things are operating. And so that's a big piece. So we run those models and near shore, offshore, and things like this to understand how that's going to happen and what that means to the data that we're seeing. We also have the Ocean Observatory Initiative. So I actually have a massive project that has $10 million worth of Dell hardware behind it and gets minute-level interval data coming from the ocean. So this is where I have literally 10 petabytes of data. And so we're allowing researchers to come in and leverage that from around the world to apply the knowledge there to everybody.
You're a kid in a candy store, important. 10 million. Seamus, come on, put some more in there.
So the ocean temperature thing is really important. I want to tie that temperature doesn't impact the plankton, right?
And a responsible way to do that is to make sure that you're getting the best performance per watt in the platforms, right? So, I mean, John, you know that like one of my other pet projects is sustainability, right? And understanding performance per watt per node means that we get the best performance. Even though we're using more TDP per unit, we're actually going to use it for a function. So we're putting all that compute into the computer architecture, not the cooling costs.
Correct. That is absolutely crucial.
You guys are awesome. We really appreciate you coming on and love the work you're doing. Appreciate what you do. It's super valuable to the world and the planet. And it must be really fun to work on that.
I do love working at Oregon State. They let me go and do all the crazy stuff I want to do to fix this planet.
I'll get off my Pac-12 soapbox in a second, but we'll talk about that offline. Seamus, put a plug in for what you're working on. I know you do a lot of hard work at Dell on the engineering side to get these products and these reference architectures out there and the work you're doing.
I mean, at this show at Supercompute, we've met with a lot of universities, right? Hundreds of universities that are here. And the big thing that I'm seeing is that we want to enable that research and innovation engine that's being developed here at Supercompute.
Chris, put a plug in for Oregon State, students watching, prospective recruits, the recruits that are out there, the students, the PhD students, the master's degree, put a plug in for what you're working on.
Yeah, I mean, in the end, we live on the backs of researchers and students. We need students to come to us to help us have these bright ideas. Okay, I've got a student right now who wants to use the plankton algorithm to find plastic and nanoparticles in the ocean. And I think, wow, that's a phenomenal idea. How do I get the money to support this woman and get her to get this done? And so I need that creativity from them. Bring that creativity to us and we will use it.
We're in an age of creativity, accelerated, superpowers with supercomputing. Thank you for coming on. Appreciate the insight. Thanks for that great insight. I'm John Furrier with Jackie McGuire from CUBE Research, doing our part to bring you the creativity and the data. Thanks for watching.